Okay, so last thing we're going to cover, or sorry, today we're going to cover, not the last thing. We got a couple more things we're going to cover, but one of the last things in derivatives that we cover is something called L'Hopital's rule. Okay, L'Hopital's rule. Now, it kind of combines limits with derivatives. It's a limits question. Well, we couldn't have done it when we did limits. You couldn't have used it on the limits test because you had no idea what a derivative was. When we took a limit, when we did the limits test, the first test of the year, limits and continuity, if I had said you can use L'Hopital's rule by taking the derivative and doing this with it, you would have been like, what's a derivative? I have no idea what a derivative is. So you can't use L'Hopital's rule until you actually know what a derivative is and how to find one. Okay? Once you do that, L'Hopital's rule is very, very useful. Okay? So this is one of the last things I do in the semester. So L'Hopital's rule, it's spelled a little differently. It's named after a Frenchman. I can't remember his first name, but his last name was L'Hopital. Sometimes it's spelled, it looks like hospital, l'hospital, but it's not. It's L'Hopitals. It's French. Okay? So L'Hopital's rule is a theorem which provides a technique to evaluate limits of indeterminate forms. Okay? So when we're doing a limit question, what's always our first method of solving a limit, evaluating a limit? What's always our first method? As x approaches 2, plug it in. See if you get a number, you're done, right? That's the limit. If you get something over 0, so if I plug in something, let's say I plug in 2 everywhere there's an x, right? And let's say I get a number, 1/4, -8. I'm done, right? Done. That's it. My answer is that number. What happens if I get a number over 0? What's the answer going to be? Yeah, the limit does not exist. DNE, right? The limit does not exist, right? So that means it was a situation like this, right? If it was a graph, probably was a situation like this, where there was jump discontinuity or something like that. Okay. What happens if I get an answer like this, 0 over 0? What did we usually do? Factor, something like that, right? We still have work left to do. That's what we're going to focus on today. So if you were to get a number like 1/4, like -8, you stop. You're done. Okay? That doesn't change. If you get a number over 0, still DNE. That doesn't change. What I'm going to help you do today is make this one a lot easier. 0 over 0. Okay? 0 over 0. I'm going to help you make that one a lot easier. What happens when we get one of those? 0 over 0 or infinity over infinity. Some people think infinity over infinity is 1. No, it's not 1. Okay? It's what we call an indeterminate form. Okay? Indeterminate. Indeterminate means we don't know, right? Indeterminate. Can't tell. Why is 0 over 0 considered an indeterminate form? Right? Indeterminate means this. I don't know. Why would 0 over 0 be considered an indeterminate form? Isn't there rules for 0 on top and 0 on bottom of a fraction? What's the rules for having 0 on a fraction? So if we get a 0 on top, that means we get 0 as an answer, right? That's one rule. Keep going. Exactly. If we get a 0 on bottom, that means we don't have a number. Undefined, right? Undefined. We know those two answers. But what if we have a 0 on top and a 0 on bottom? Is the answer 0 or is it undefined? We don't know. That's why it's called indeterminate form. We don't know. Okay? We don't know because it falls under both rules. 0 on top equals 0. 0 on bottom equals undefined. But if it has both, we don't know. Okay? So anytime You plug in chug, you plug in a number, and you get 0 over 0. You can always use L'Hopital's rule. Okay, and I suggest using it. From now on, use it. Okay, what is L'Hopital's rule? L'Hopital's rule says this. If I have a value, if I'm finding the limit, and I plug in a number and I get 0, plug in another number, I get 0. If I get an indeterminate form, or if I plug in 0, if I get 0, not 0, if I get infinity over infinity, I can use L'Hopital's rule. L'Hopital's rule says find the derivative of the top, find the derivative of the bottom, do the same thing until you get an answer. So find the derivative of the top function, find the derivative of the bottom function, and do the same process over again. Okay? We can only use L'Hopital's rule when we get an indeterminate form. I can't just go, you do L'Hopital's rule. Right? I have to make sure it's an indeterminate form before I use L'Hopital's. Okay? All right, so let's look at example number 1. Anytime you're doing a limits question, whether you do it in your head or whether you do it on paper, you should always plug in the limit as x approaches 2. I'm going to plug that in and see what I get. Okay, obviously I can see on the bottom I'm going to get 0. 2 minus 2 is 0. Okay, now let's see what I get at the top. So I get 3 times x squared minus 7 times x plus 2. So 2 squared is 4 times 3 is 12 minus 14 plus 2. That's going to be 0. 0 over 0, right? So whether you do that in your head or whether you do it like I did, check. Always check. First check. Indeterminate form. Once you get that, then it's okay to use L'Hopital's rule. So L'Hopital's rule says, first thing you're going to do is you're going to take the derivative of the top. Okay? So rewrite the problem. Limit as x approaches 2. The derivative of the top, the green, that's going to be 6x minus 7. Now take the derivative of the bottom, which is 1, right? Plug it in again. So 6 times 2 minus 7 over 1. 12 minus 7 over 1 equals 5. So the limit as x approaches 2 is 5. Okay? Last semester, we factored this guy. And then canceled something out and did it that way. That still works. The way you did it on your first chapter, that still works. But this way, I think you're going to find is a lot easier. Goes a lot quicker. Okay? Number 2. Number 2. Plug in -3. So I get -3 plus 3. And then I get -3 squared minus 5 minus 2. So I get 0 on top. On bottom, I get square root of 9 minus 5 is 4. Square root of 4 is 2. Minus 2, I get 0 over 0. Okay? So I can't, so again, means I can use L'Hopital's. So what I'm going to do is I'm going to take the derivative of the top, derivative of the bottom, try it again. Okay, so first thing I got to do is find derivative of the top. The derivative of the top is just 1. Derivative of the bottom. Okay, the bottom is a little different. I'm going to do the bottom over here. So it's x squared minus 5 to the 1/2 minus 2. That's what the bottom says. Well, minus 2 is nothing. The derivative of minus 2 is just 0. So you're just going to focus on the first part. Chain rule. 1/2 x squared minus 5 to the negative 1/2 times 2x. The 2's cancel each other out. So you're left with x times x squared minus 5 to the negative 1/2. Plug in again. I'm not worried about negative 1/2 because I'm just plugging it in. Okay, so I just want to plug it in to see what I get. So we'll plug in negative 3 again. So we get 1 over negative 3 times negative 3 squared minus 5 to the negative 1/2 power. So we get negative 3 times 4 to the negative 1/2 power. Because negative 3 squared is 9 minus 5 is 4. No, I canceled out the 2's. Yeah, see the 1/2 with the times 2? I canceled them out. You don't have to do that, but I did that just to simplify it. Yeah. Yeah, so if you can multiply times 2, just make sure you have the 1/2 in front too. Okay, yeah. Okay. Okay, so we got to do exponents first. Exponents before multiply. I can't multiply. I can't multiply negative 3 and 4 because I have exponents. Well, what does negative 1/2 power mean? Square root, and take the square root as one thing, and there you go. Yeah, that's what that means. It's negative 3 times 1 over the square root of 4. That's what negative 1/2 means. It means flip. That's what the negative means. And then find the square root. Okay. So I get 1 over negative 3. Square root of 4 is just 2. Okay. So I get, move it over here. You're going to get 1 over negative 3 over 2. So you get 1 divided by negative 3 over 2, multiplied by the reciprocal of the second, and you're going to get negative 2/3. Negative 2/3. So the only calculus we do here is the derivative. Everything else, just plug in, just like you normally would. Plug it in. If you get an answer, you don't have to use L'Hopital's rule. Don't have to use it. If you get something over 0, D&E does not exist. If you get 0 over 0, that's when we use L'Hopital's rule. That's when we use L'Hopital's rule. Okay? All right, so I want you to try number 3. I want you to try number 3. Make sure you verify you can use L'Hopital's rule. Don't just assume, oh yeah, it's L'Hopital's rule problem. Okay, so I plugged in negative 2 everywhere I saw an x, got 0 on top. Plugged in negative 2 everywhere I saw an x on the bottom, got 0 on bottom. Okay, now I know I can use L'Hopital's rule. L'Hopital's rule, find the derivative of the top, find the derivative of the bottom, try again. Three x squared plus 2x minus 8. 3x squared plus 16x plus 20. And we're going to try again. Okay, so I plug in -2 everywhere I see an x. I get 12 minus 4 minus 8. And then on the bottom, I get 12 minus 32 plus 20. On top, I get 12 minus 4 is -8. Or sorry, 8 minus 8 is 0, so I get 0 on top. That's okay. Doesn't mean anything wrong. It could be just 0 as an answer. On bottom, I get 12 minus 32 is -20 plus 20 makes a 0 as well. So we got indeterminate form again. What do you think we're going to do? Take a wild guess. What do you think we're going to do? Yeah, do it again. Do the process again until we get an answer that's not indeterminate. So we're going to get 6x plus 2, 6x plus 16. So plug in -2, plug in -2. So -12 plus 2, -12 plus 16. -10 over 4, -5 over 2. That's the limit. Okay. All right. Okay, so that's L'Hopital's rule. So pretty much everything else is just questions about that. Number 4 is the exact same type of question. You've seen number 4 type of question before. It's just a trig function. That's all it is, trig. For finding the limit, the first thing we're going to do is always plug in the value. Plug in what is x approaching? 0. So I'm going to plug in 2 times sine of 0 minus sine of 2 times 0 over sine of 0 minus 0 times cosine of 0. Okay. So the top 2 times sine of 0 is just 0. Anywhere I see a sine of 0, it's just 0. So I see a sine of 0 here. I see a sine of 0 here. I see a sine of 0 here. So 2 times 0 minus 0, 0. Cosine of 0 is actually 1. But it's being multiplied times 0. So 0 minus 0 times 1 is just 0. Indeterminate form. Okay? Indeterminate form means find the derivative. Okay? So find the derivative of the top, find the derivative of the bottom. Well, the top has 2 parts. It has 2 times sine of x, and it has sine of 2x. The first one, we're just going to find the derivative. So the derivative of sine is cosine. 2 times cosine of x minus. The second part, we're going to have to use the chain rule for this guy right here. Okay. So the derivative of sine is cosine, 2x, times the derivative of the inside, which is just 2. The bottom, again, it has 2 parts as well. It has 2 terms. The first term is sine x. Derivative of sine x is just cosine x. Minus x times cosine x. That's a x is a function times cosine, which is another function. So when we take derivative of 2 functions multiplying times each other, we have to use a product rule. Okay? So you take the first times the derivative of the second, which is going to be negative sine of x plus the opposite. The derivative of the first is just x, or sorry, 1 times cosine. So it's just cosine of x. Okay? Everywhere I see an x, I'm going to plug in a 0 again. 2 times cosine of 0 minus cosine of 2 times 0, which is just 0, times 2. Cosine of 0 minus 0 times negative sine of 0 plus cosine of 0. Cosine of 0 is 1. So 2 times 1 minus cosine of 0 is 1 times 2. 2 times 1. Bottom, cosine of 0 is 1 minus, and then over here I have some parts to it. So 0 times sine of 0, that's just 0 times 0. Cosine of 0 is 1. Zero over 0. Okay, so now I got to go back, and I'm going to find the derivative of this guy again. This top and this bottom. Okay. So limit as x approaches 0. Okay. Don't look at me for my moves, because by the time you look, if you're doing this, if you're up and down, up, you're going to lose track. So try it on your own. Try it on your own, and then after you're done, tweak it. Okay? Because if you're doing one of these up, down, you're looking up, looking down to your paper, looking up, looking down. If you're doing one of these like a tennis match, you're going to lose. You're going to lose, right? So try it on your own. You guys know how to find derivatives. If you get it wrong afterwards, if you get it wrong, then you can change it. Okay? But yeah. So 2 times cosine of x. 2 times cosine of x is 2. The derivative of that is just going to be 2 times negative sine. So I'm going to put the negative in front. Minus. Okay. The next part. This guy right here. 2. I'm going to put the 2 in front again. So it's just going to be 2 times. And then I got to do chain rule again. So it's going to be negative sine of 2x times another 2. Okay, and then the bottom got 2 parts as well. cosine of x, the derivative is just negative sine. So negative sine of x minus okay, so this guy in here. Inside the second term, I have two terms. One here and one here. Inside the first one, I have to use product rule. So product rule is going to be first times the derivative of the second. So x, the derivative of negative sine is negative cosine, plus 1 times negative sine, and then the derivative of cosine is negative sine of x. So I'm gonna clean this up a little bit before I plug in 0. Negative 2 sine of x. Then I have two negatives here where I'm going to cancel out and make a 4 plus 4 sine of 2x. Okay. The bottom, I have a negative sine of x minus, and then I'm going to have a negative x cosine of x minus sine of x minus sine of x, or 2 sine of x. Okay. You can distribute the negative here, so this will be positive, and then you're going to change these signs here. Since everything's negative, just change it. If you distribute the negative, it would make it positive. Okay, plug in 0. Everywhere you see an x, plug in 0, and hope and pray that you don't get you get something other than 0 over 0. Because if we get 0 over 0 again, you know what we got to do. We don't want to do that. So let's just do this slowly and methodically so that we know, so we don't make any mistakes. Okay, so negative 2 sine of 0. An easy way to do this is anywhere you have sine of 0, it's just going to be 0. So I'm going to save some time and not have it. I'm not even going to write sine of 0. Anywhere I have sine of 0, it's just going to be 0. So this guy right here, use a different color. This guy right here is negative 2 times sine of x. Well, that's just going to be 0, because sine of 0 is 0. Same thing over here, right? So far we got 0 on top. Let's pray we don't get 0 on bottom. Sine of x, 0. Sine of x, 0. Sine of x, 0. I don't have a sine of x on bottom, though. But is it going to be 0? Yeah. Because it's 0 times 1, which is 0. I'm not going to make you finish. I'm not going to make you do it again. If you want to do it on your own time, you can figure out the answer, but you just get the idea. The exercise is good enough. Okay? If you got enough time and you want to be crazy, go for it. You can do it from there, but I'm not going to make you. I think we should go on to another problem. But you get the idea. Okay? You got to be careful with some of these, especially the ones with sines and cosines. And if you're plugging in 0, because you're going to get 0 a lot. Tangent of 0 is 0. Okay, we'll see another one later, like this. Okay, number 5. Number 5 is different because it's no longer a value, right? It's no longer a value. It's infinity. How do we deal with limits that approach either positive infinity or negative infinity? What was the rules there? How did we do that? What's that? Something with the exponents. Has something to do with the exponents. What did we do with those? What was our process? Anytime we had something with an infinity, as x approaches infinity. So like number 5 or number 8. What was our process? It's very, very first chapter. We had this stuff here. It's good that you're finding it because we're going to need it this chapter because we're dealing with limits. So for limits at infinity, so as we're approaching either positive infinity or negative infinity, they fit into 3 categories. The first category is top heavy. Second category, bottom heavy or equally balanced. What do I mean by that? I mean the degree. We look at the degree. What is the degree of a function? When I say the degree of a function, what am I talking about? There you go. The highest exponent. The highest exponent. We compare them. That's how we do these. Okay? So let's go back and look at number 5. So what is the degree on top? What is the degree on bottom? What do our notes tell us if they have the same degree on top and bottom? Equally balanced. So what is our answer going to be? A ratio of the leading coefficients, right? A ratio of the leading coefficients. Well, where do we look for with leading coefficients? I'm talking about this in my Math 3 class, leading coefficients, which means you guys talked about it last year. What are the leading coefficients? Why not -1 and +1? Because the leading coefficients are always the numbers with the degrees. 3 and 2 are the coefficients that have the degree. So those are going to be it. So for this problem, it's going to be 3/2. 3/2. You can actually use L'Hopital's rule on this question, but don't worry about it. I would just do it the same way we did. Go back to this guy right here. L'Hopital's rule says this. The way I would use L'Hopital's for this guy is I would plug in this. So in other words, I'd do it like this. I would say 3 times infinity squared minus 1 over 3 times infinity squared plus 1. Infinity is a value, is a theoretical value. It's not a real value. It's a theoretical value that's really, really high, right? So these guys wouldn't matter. So just focus on these guys here. And really, you would get a really big number over a really big number, right? L'Hopital's rule. So then you would 6x over 4x. You'd still get infinity over infinity. You do it again, you finally you get 3/2. That's how you would use L'Hopital's. You don't need to use L'Hopital's for these guys. Just use what we did when we did this chapter. Okay? That's why I brought that up. Because you will see those, and you're like, how do we use L'Hopital's there? You don't. You just use the table. Okay? Okay, number 6. Number 6. So plug in 0 and see what you get. anything to the 0 power is always going to be 1. So it's going to be 1 over 1 minus 0. So L'Hopital's rule. Okay? So let's find the derivative of the top and the derivative of the bottom. Derivatives of e's and ln's. You'll always see those. AP loves e's and ln's. They love them. They're all over the place. They do that because it's intimidating. When you see e's and ln's, they're intimidating. But they're actually one of the easiest things to find derivatives of. E to the 3x. How do I find derivative of e to the 3x? What's the first thing it always does? Not yet. What's the first thing we always do first? Starts with an R. Repeats itself. Always repeats itself. First thing you do, repeats itself. Okay? Then, what do we do? Find the derivative of the exponent, which is 3 in this case. Okay? The derivative of 1 is just 0. So I don't even need those. Derivative of x is 1. Plug in 0 again. I get 3 times e to the 0 power over 1. So 3 times 1 over 1, 3. Anytime you have to do derivatives of e's and ln's, that's stuff you want to find derivatives of because they're very, I don't want to say easy, but they're not as bad as it looks, right? Like if you have if you have to find the derivative of this guy here, natural log of 2x squared plus 4. A lot of people get scared. Oh, what? It's just, first thing you do, put it over itself, and then you find the derivative of the inside. 4x. Done. Okay? So, as we start reviewing for the final, you're going to see a lot of those because the questions I give you are just old AP questions. And old AP questions are a lot of E's and a lot of LNs. Okay? All right, so do number 7. Why don't you do number 7 now? Okay, so you plug in 0 top, you plug in 0 on the bottom, you get 0 of 0. Okay, so that means we're going to find derivative. Tangent of 0 is 0. Okay, so 2 times the derivative of tangent. So the top, 2 times derivative of tangent. Do I have to use product rule for that? No, because 2 is a coefficient. It's not a function. It's just a coefficient. If it was 2x, yes, but not, I don't have to use product rule for that. So 2 times the derivative of tangent is secant squared. So secant squared of x. The bottom is just 5. So be careful, again, be careful with secant squared. That's how they write it in trig, but it doesn't really make that much sense to me because it's like, what do you square? Do you square the secant? Do you square the x? What do you square? So this is how I write it. Because that's what it means. It means your answer squared. Whatever answer you get, you're going to square it. That's what secant squared means. So what sine squared means. Cosine squared. Okay, so I'm going to plug in 0. Secant of 0. What is secant of 0? Those of you guys that have your tables out. What is secant of 0? Just positive 1? Two-fifths? Done. Okay. Doesn't matter if the answer is ugly. If it's not a 0 over 0, you don't need to use L'Hopital's rule. So even if it was like pi over 2 or square root of 2, square root of 2 over 3, that's an ugly answer, but still, it's a number. We're just going until we get a value that's not indeterminate. Okay? All right, so tomorrow what we're going to do is we're going to finish these. Then I'll give you some time in class to start on the assignment. Okay, so we'll take about 5 or 10 minutes to finish these. And then the rest of the time I'll give you guys to practice on your own. Okay? It'll either be on Delta Math or I'll give you a worksheet. I haven't decided yet. So I'll give you some time to do that. All right, guys.